Hello everyone, I am Yashcvora and this is an internship project organized by the Spark Foundation. So in this project, our task is to do the prediction using the unsupervised ML. The main problem statement is here we are using the k-means clustering method to predict the optimum number of the clusters and represent it visually using the iris dataset. So this is a dataset link. There are 6 columns in this dataset. So these are the 6 columns. Now we are importing some required libraries like the Pandas for performing data analysis and data manipulation operation, Numpy for performing mathematical operation, and creating n-dimensional array. For visualization, we are using the Matplotlib and Seaborn. For model creation, we are using the k-means clustering. Then for model evaluation, we are using the cell to score. Then we are loading the data set. So this is our data set. Now we are dropping the id and the species column as it is not needed, because in the k-means clustering we only have the input data. So this species is basically our output data, so it is not needed, so we are dropping it, and id is also not needed, so we are also dropping that column. So this is our data, this is our input data. So now we are doing some statistical analysis on the data using the describe function, like the count, mean, standard deviation, minimum, first quartile, second quartile, third quartile, and the maximum value. Then some basic information about the data. Then checking the null values in the data, it is 0. Then we are plotting the pair plot for the multivariate analysis. So this is how it looks. And then we are using the elbow method for finding out the optimum number of the cluster. Here simply I have created a function for finding out, for calculating the optimum number of the cluster. So here I have done I have created a WCSS empty list, then use the for loop that actually iterate up from 1 to 10. So here we are doing using the k-means clustering for 10 different clusters, and we are fitting the model and appending it into this empty list, and then we are plotting it graphically, and then we are calling it this function and providing this data set. And this is something the elbow method looks like. So here we can clearly see that as the number of the cluster increases, the WCSS score is decreasing, but after the third number of the cluster, the WCSS score doesn't decrease significantly with the each iteration. So here from this we can choose the number of the cluster value as 3. So now we are building the model with the 3 clusters. So this is how the model is initialized, and we are fitting the data with this model, and now our model is trained. And then we are finding out which value is assigned to which clusters. Okay, so for that this is a value that is assigned to the each of the cluster, and so this is basically used to find out the value that is assigned to the each of the cluster, and then we are creating a separate column for the cluster. So here for the first row is basically assigned to the number 1 cluster, and then we are calculating the cluster centered by this method cluster centered. So there are 3 clusters, so there are the 3 different centroid value. Centroid is basically the mean value for each of the clusters. Then now we are presenting that how cluster along with the centroid is represented visually. Okay, so this is how something it look like. So here we are visualizing the cluster for the first 2 columns, and here we can clearly see that the red points, this red points, that is the iris address, is our first cluster, and this yellow point, it is this cluster centroid. Then this green color is the another cluster, and this yellow point is the centroid of this cluster, and this blue point is the another cluster, third number of the cluster, and this yellow point is the centroid of this cluster. So this is how it look like. And at last we are doing the model evaluation, using the Silhouette score. The Silhouette score is basically used to check how our data points is actually assigned to each of the cluster, how accurately our data point is assigned to the each of the clusters. So its value is nearly about 68%, 0.68. Okay, so now we are concluding our video here. And if you have any queries regarding this solution, then you can comment down below. And if you like my content, then please share with others. Thank you.